Hi, I'm Jeff Cogswell. Today I want to talk about the hardware design of the Xeon Phi Coprocessor. To get started, I'm going to use some images that Jim Jeffers and James Reinders of Intel were kind enough to supply us with. These images are freely available on their website. If you want to use them in your own presentations, you can go to www.lotsofcores.com. Okay, so when you buy a Xeon Phi coprocessor, you don't actually just buy the chip itself and install it inside your computer. Instead, you buy an entire board that contains the chip. The board plugs into a PCI Express slot on your computer, and this is a diagram of the board. First thing you can see is the main coprocessor right here, the Xeon Phi. Beyond that, down here in the corner, you've got the flash memory. This is just a small little piece of memory that contains the boot up code. So when you boot this thing up, the first thing it does is run the code that's stored in this flash memory. Around here, you've got 16 channels that connect to the memory. The memory is GDDR5 memory, which is a higher bandwidth memory than what you find typically in a regular computer. The reason is the coprocessor is running as many as 144 threads throughout 61 cores, and it's going to need the higher performance of faster memory than what you would normally find with the memory we usually use. So they decided to use this GDDR5 memory, which was originally used in graphics processors. And graphics processors typically have multiple cores, and so it lended itself real nicely to this case. Now, the next thing down here is the SMC. That's the System Management Controller. This has several sensors tied to it that measure physical characteristics of the card, such as temperature control, voltage, and whatnot. And from there, in conjunction with the operating system code, you can decide whether to turn the fan on and off. Now, not all of these cards have fans. You can get cards with fans or without. For those that don't have fans, the typical way to use them is in a rack that has its own cooling system or even liquid cooled. Then over here we've got power connectors. If your computer supplies the right voltage and power through the PCI slot, you'll be fine. You won't need external power, but not all systems do, in which case you will have to supply external power. Now, the one thing that you may notice is missing from here is a hard drive. This is a coprocessor, but it is an entire computer in its own right, with the memory and the processor and the cooling unit and everything here. The reason it doesn't have a hard drive is you have your own hard drive on your host computer. Now, this doesn't have access to your host computer's hard drive, but when you boot this thing up, you push the code across to this thing. The way that works is when you boot up your computer, you then start up a separate service that you need to install. It's called the Intel Mini Core Platform Software Stack Service, or MPSS service. And that service takes files that are Linux and pushes those files across to this processor into this GDR memory. And then the processor executes that code, which is just the Linux kernel, along with some other customized code that Intel created for its own version of Linux that runs on this thing. And what's interesting there is with that Linux, it exists on your own hard drive initially, including a whole bunch of text files that are configuration files. And that means you can actually go in and modify those and configure the Linux exactly how you want. And the Linux is also open source, as is any Linux. And so you can take the source code and even modify it yourself if that's what you want to do with this thing. So there's a lot of possibilities here with this. And that's the fundamental architecture of how this works.